All right, ladies and gentlemen, I'm excited to show you a little bit about Excel and statistics. So we're going to get started. And here's some objectives for this lesson. We're going to start by, hopefully at the end of this, we're going to learn how to interpret the meaning of something called the correlation coefficient. It's a mathematical idea that's in statistics. Then we're going to learn how to specifically use Microsoft Excel to calculate the correlation coefficient between two sets of data, and also to calculate the average of a set of numbers. That's a basic math concept. So here's the docket. We'll start with what correlation coefficients are, then we'll talk about correlation inside Excel, and then we'll learn how to use Excel to calculate averages as well. Okay, so before we can discuss further how to use correlation or what the correlation coefficient is, we first have to define what correlation means. And I think many of you may have learned this before, but I want to just reintroduce it. So first of all, if two sets of data share some kind of relationship, they're said to correlate. Okay, and that means that they're connected. They share some kind of relationship. If two data sets show correlation, that means that we can predict the behavior of one data set from the other. So for example, here's two graphs, and they're both going up. They're of a stock's value. There's stock X and stock Y, and they're both increasing over time, which is the x-axis in this graph. So we can say that the behaviors of these two stocks are correlated because as one goes up, the other one is also going up. The behavior of one has a relationship to the behavior of the other. So let me give you some further examples. There's a strong positive correlation between college degree level and salary. So if you take a look at the degree that someone has, like whether it's a associate's degree, a bachelor's degree, or maybe a PhD, the eventual bling that they're going to end up with, those are correlated because the more years you spend in school, the more money your salary tends to be when you get out. Okay, so there's a relationship there. As one increases, the other one increases as well. There's a strong negative correlation between the amount of McDonald's cheeseburgers eaten and your average life expectancy. So there's still a correlation between these two things. If you've seen the movie Super Size Me, the more cheeseburgers you eat from McDonald's, the less you're going to live. Okay, so as one goes up, the other one goes down. But that's still a relationship, right? As one increases, the other one decreases. We can predict that if you have 1 million McDonald's cheeseburgers, you might not live as long as somebody that doesn't. Okay, and so that means that there is still a correlation even though one goes up and the other one goes down. We'll talk about what it means for there to be no correlation in a second. Okay, so in math and in statistics, we have this term called the correlation coefficient, and it's usually denoted as R, okay? And it tells us how closely connected two data sets are. It shows us how close their relationship is. The closer the R is to 0, the less correlated the two data sets are. So if you have an R of 0, then you're not correlated at all. So let's talk about some examples again. Here, if R is -1, that's like a super strong, if not perfect, negative correlation. Okay, so that's the most negative a correlation could be. That would mean that increases in one variable correspond to decreases in the other. So that's similar to our McDonald's example a second ago. If I take the number of double downs that you eat, that's the nasty sandwich from KFC, and the number of birthdays that you're going to have in your lifetime, increases in one bring about decreases in the other, and they're very strongly related, so the R is -1. Okay, if there's no correlation, however, that means that the two variables are totally unconnected. There's no connection between them at all. So for example, your race and your IQ are completely unrelated. There's no correlation to them at all. It's not as though African American people are more intelligent or Asian people are more intelligent or white people are more intelligent. There's no correlation between those two data sets. Okay, so that's an R of 0, whereas if one goes up and the other goes down, that's an R of -1. And then there's also a strong positive correlation, which is if one variable goes up, the other one goes up as well. So an example of that is the one from before. The more years I spend in school, the more moolah I'm going to end up with when I'm older. Now, most of the time, you're not going to end up with a data set that exists exactly at -1 or exactly at 1 or exactly at 0, but you're going to find a correlation coefficient somewhere in between, okay? But the closer to 1 you are, the stronger your positive correlation is. The closer to -1 you are, the stronger your negative correlation is. And the closer to 0 you are, the less connected your variables are altogether. All right, so I'm going to show you how to do this in Excel, and we're going to use a pretty good example. All right, so we're here in Excel now, and I've got a lovely piece of data for us to work with. And again, I've made these pieces of data up for this whole lesson, but it will help to illustrate the point. So what I've got here is I've got 11 students, and they each took the SAT once, and then they did some studying over the course of 1 month, and then they took the SATs again, a different set of SATs, but the same test twice with some studying in between. And so you can see the first column, A1, which is right here. You can see in this column, the students have gotten their first score, and then in the second column, which is column B, is the number of hours that they spent studying between the two tests, and then in the last column, this is the score they got the second time that they took the test. That is. Okay, so what can we do with this data? We can try to figure out if there's some correlation between how hard they studied and how well they did the second time. And so Excel is really beautiful for doing this, but before we can really do anything with this data, we need to get one more piece of data to play with. So it doesn't matter how hard you study, right? You might be really, really smart or really, really stupid, and as a result, you might get a high score on the SATs or a low score on the SATs. But what we're looking to evaluate is whether your studying helps you get better from the first to the second time. Does that make sense? So we need to make sure that we have a measure for whether or not somebody improved from one test to the other. And so to do that, I'm going to make a new column right here, and I'm going to call it SAT, or I'll call it score change. Okay, so this will tell us how much the score has changed from one thing to the other. So we're going to have to use a calculation to figure that out. And we'll try to use the first, this row here, row 2, as a sample. Okay, so this person had 1610 the first time they took it, not a bad score. Then they studied for a whole while, and they got 1700 the second time. So how much did their score change? Their score went up by 90, right? And the way I can get that is I can say, all right, I use an equal sign because I'm about to use some math. And I say, all right, this score minus the other score tells you how much the score has changed, right? And we should get 90 because the score went up by 90 points, and there you go. To fill this out all the way down the columns, of course, we can grab the corner until we get that plus sign and drag it all the way down. If you've never used formulas in Excel, or if you're not familiar with that drag operation I just did, then you might want to go watch another video that I have on here that talks about formulas and calculations in Excel. All right, so now we know how much their score has changed from the first test to the second. Now here's the best step, the most important step, is to calculate the correlation coefficient. Excel has a built-in function that's designed to do exactly that, and whenever we're using math in Excel, we start by typing an equal sign. Okay, and then the function that we use for correlation in Excel is called correl. Okay, it's spelled C-O-R-R-E-L, and then you open up parentheses because you're using a function. And then Excel gives us a little hint about how to use this thing. It says we put in the two arrays, which are the two sets of data, and it's going to return us the correlation coefficient. So we pick one set of data. Here we go. I'm going to drag and just select the numbers. Okay, and then to differentiate between the two sets of data, you hit a comma, just as it has in the example there right under the formula, and then you drag and select the other set of data. So we want to see if there's any correlation between the change in the person's score and how much they studied. So here we go. I've selected it all, and then you just close the parentheses and hit enter. And Excel turns all the cranks, and it comes up with the answer, and it tells us these two numbers have a correlation coefficient of 0.78. That's a pretty high level of correlation. Anything close to 1 means that those two things are positively correlated, which means that increases in the hours spent studying resulted in increases in the score change. And that makes sense, right? The more you study for the SATs, the better you're going to do. And that's why we ended up with a 0.78 here. It tells us that these two sets of data are correlated. Okay, so I just want to show you one last time how this whole process goes down. To do this, you simply hit the equal sign, and then you type in correl, C-O-R-R-E-L, short for correlation. Then you open a parentheses, and then you select the data range that you're interested in for the first column, and then the data range that you're interested in for the second column. And you separate them by a comma, just as is indicated to you by this little pop-up window, which says array1, comma, array2, close parentheses. And that tells us, yep, give me the first set, comma, the second set, and close your parentheses. So we'll get the first set. It is this set right here. And there we go. And I accidentally closed the parentheses, but that wasn't correct. And then I add a comma to indicate now I'm giving it the second set. And I go ahead and do just that. I click and drag and grab the second set of data. And here I have it. And then I close the parentheses and hit enter. And here we go. I'm going to get my correlation coefficient. Excel is going to do the math, and again I get the same number, 0.78, which is a pretty high level of correlation. Alright, so that brings us to our first pause moment. We're going to try and learn how to do this and try it out on our own. So we're going to start by downloading the first practice Excel sheet. It should be linked along with this file. I've made this data up. It's not real. But the data shows the number of hurricanes in the last 10 years. And it also shows the amount of carbon dioxide in the atmosphere over the last 10 years. Okay? And your task is to find the correlation coefficient between the two sets of data. And then I want you to tell me, what does that coefficient mean about the data? What does it tell us about the relationship between those two data sets?